without much ado, I want to introduce who is our Director of Partnerships. He also doubles as the Chief Revenue Officer for EVTT. So, facilitates today's session on introduction to proprietary. He will start by introducing himself, give a bit of his background, and then you have the floor.
Thank you, God. Good afternoon, good morning, ladies. I hope you're okay. Give me a minute to share my screen.
I think that was why he's like, it doesn't come to this muscle. I think he's expecting the good. So
Great. Yeah, so as God has said, my name is John Msingo. I'm the Chief Revenue Officer of EVTT Limited. EVTT supplies, installs, operates, and maintains four-wheeler electric vehicle charging infrastructure. So we're a startup based here in Nairobi, Kenya. I also am the Director of Partnerships, and that's a role that I've held for almost 4 years right now at Africa NEV. Very proud of the work that we're doing in Africa NEV. The photos that you're seeing are technical trainings that Africa NEV organized. So we organized the technical training last year in May, the first ever open EV technician training in Eastern Africa. The second one was done in January at Rome. And these are just pictures from some of them. On the first one, can you see my cursor? Okay, so the first one was, we're looking at a battery pack for a Nissan Leaf. The second one, we're looking at power inverter. Great. So let's start. If you look at electrification in Kenya, you'll notice that from 2014 up to 2020, there was a percentage increase, from 32 to 70. That means that people who are connected to power almost doubled. And this was done mainly because of a project known as the Last Mile, and it was funded by the World Bank. Yes, so it's all well and good. Project was done. And if you look a bit deeper, these are some numbers. So from 2012 on the green curve, so on the blue curve, you can see the number of customers rising. The number of customers rising steadily from 2012 up to 2018. But on the green curve, what we're seeing is that as of 2012, each domestic customer would pay about $12 a month on average. But that number has steadily been decreasing up to 2018, where we get to about $4. It's about right, slightly above 4, so maybe around $5. The monthly power bills of about 3.6 million households of the 6.5 million connected to the national grid is 305 Kenya shillings or roughly 2.3 US dollars a month. I want that number to sink in. That means that for more than 3.6 million households, they use less than $2.3 in terms of value of electricity. That's less than 15 kilowatt hours a month. Next slide. Just looking deeper and still looking deeper into those numbers again, you can see in terms of, let's take the dark blue one, domestic again. You can see the percentage increase is going up. Fantastic. You can see the small commercial, the small commercial going down. And then you can look at the commercial and industrial going further down. This is as a result of many things. But for the commercial and the industrial, chief among them is companies are now moving towards self-generation of power. So what we are having is that your grid is not serving you the way you want. You're looking at it, you're saying that I will now go and put up solar panels and I will be able to power and produce my own power. We have people who've done even up to hydro projects. Some have even done biomass projects. And if you look at the second graph, this is extremely detrimental to Kenya Power. Kenya Power is our utility because 90% of revenue comes from less than 10,000 customers. Remember here on this previous slide, Kenya Power, as of 2018, had roughly about 6.5 million customers, right? But when you come to this side, we're talking about 90% of their revenue coming from less than 10,000 customers. So what does that happen? What happens? You can see the terms of net profitability of Kenya Power. Tanks. And this is a trend that we are seeing being played out in the whole of Africa. In whichever country you are in, be it Nigeria, Ghana, it is important for you to be able to just understand the dynamics of the energy ecosystem. Because the energy ecosystem is what will power e-mobility. From all the data that I have given you, I would just like one or two people to just be able to tell me what they think that some of the results of such a thing would be. If anyone can just raise their hand, or if anyone can actually type in. What do you think the results of everything that I have told you so far? What do you expect to happen? Or should I call out someone? Sasha. Sasha? Or anyone else? Well, what do you think that the results of that are? Anyone? Okay. The main major result of that will be a weakening of our grid systems. This means that Kenya Power will continue becoming less and less and less profitable. And when that happens, what then happens again? We now have frequent blackouts. We now have unreliable power and all those other things. One of the reasons personally that I actually entered e-mobility is a country cannot, and this goes to my next slide, a country cannot prosper with low energy usage. I'll repeat that again. A country cannot prosper economically with low energy usage. If you look at this graph, you'll be able to clearly see that, look at the countries at the top. Norway, United States, Canada, Ireland, Germany, the UK, Japan. You can see directly proportional in terms of income per capita and the electricity that is consumed in the country. Look at China, and then lower down here, you can see Burundi, Somalia, Ethiopia, Rwanda, Madagascar, Mozambique is doing a bit better. But this clearly shows you that economic development is directly tied to the amount of energy that we consume. That's number one. Number two, in Kenya, we use about 500 million US dollars a month to import fuel. $500 million a month. That's a lot. And if you look at most African countries, you will find that at least in terms of foreign exchange leaving their shores, number 1, 2, 3. Number 1, 2, 3 reasons, at least out of the top 5, you'll find 2. Cars and fuel. So like Kenya uses $500 million a month to import fuel. In the video that I told you guys to watch, you saw the whole process of energy generation. So you saw from the generation to the transmission until finally distribution. A lot of African countries do not have developed grids. What do you think if we could just be, instead of paying like for the instance of Kenya, $500 million, taking it to Saudi and all those other places, what if you could just have a fraction of that remaining in our countries, and then that amount helping our distribution, that amount is also invested in our transmission, and that same amount is actually invested in our generation. That is the reason that I actually get into e-mobility, and that's the reason why I am extremely passionate about this topic. This is an economic rights issue. If we are able to just save the part of the amount that we use for fuel and let that actually remain within our borders, I think Africa will change. And that is why, as African Nev, we're extremely passionate about it. Extremely passionate about it. So to start off today's lesson, I am done teaching. Kindly, can someone mute? Thank you. So in last week's lessons, you are actually shown the main components of an electric vehicle. So we'll quickly just go through them again. Number one, we have the motor. The motor powers the wheels. The motor drives the wheels, sorry. Number two, we have the battery. Number three, we have the onboard charger. Number four, the charging inlet for an AC. And number five, we have the charging inlet for a DC. So just try and look at the schematic. In terms for the charging inlet for a DC, you can see that, and that is number five. You can see that it is going direct to the battery. That means that whenever you're charging a vehicle in DC format, it is going straight into the battery. But for the AC, it's a bit different. As you can see, number four, you plug it in, it goes into an onboard charger, and then it goes into the battery. Next slide. This is the same schematic, but for the AC side.
Please, the slides. I think we are still on the slide of total kilowatt hours sold. The slides.
You're on which slide, Gad?
The slides. Can you? I'm still saying total kilowatt hours sold versus profitability of Kenya Power. I don't know what everybody else is saying.
Kindly let me stop sharing and start again. Can you see my screen now? Gad. Gad.
Yeah. I think you're not yet appeared. You're trying to share, I believe. But we are not yet seeing. I don't know where's my network. I will give it 10 minutes. Are you sharing the slides yourself?
Yes. Can you see my screen now?
Oh.
John, I can see the screen.
They can see. Somebody will say, you can see your screen. I can't, but if you can see, that's fine.
Okay, thank you. Abigail, from where did you drop off? In terms of where were you not seeing my screen?
The slide was still in the total probability, the previous page. You were supposed to show us the part of the vehicles again.
This side, huh? This one?
Yeah.
Okay. Can you see my pointer?
You left, yeah. Yes.
You can see my pointer, right?
Yes.
Fantastic. Thank you. Okay, so I think I'll just start explaining again from here. You can see that these are the main components of an EV. These are things that were covered in the last lecture. Well, we have 5 main parts of an electric vehicle: the electric motor, which is number 1, the battery, onboard charger, charging inlet, AC and charging inlet DC. If we just start with number 5, which is the charging inlet DC, what this means is that that charging port takes in direct current, and that direct current goes straight into the battery. No intermediary in between. If you look at number 4, we have the charging inlet, which is an AC. Now, the charging inlet, which is an AC, takes in AC power, goes through the onboard charger, and then finally makes it to the battery. Next slide. What we're looking at is the schematic of the battery electric AC charging electric schematic. If you look at where it's starting from, you can see my pointer. We have 1-phase or 3-phase AC supply. That AC supply goes into here. So it goes in as AC. It is converted to DC, then goes straight to the battery. I hope that is clear. If you look at this, we have the bidirectional converter. The bidirectional converter is a DC to DC converter. So what happens is that it takes power from the battery, which is usually 400 volts, and in high-spec cars, sometimes 800 volts, takes it all the way to the motor. The motor drive changes the DC to AC, and that AC is what powers the motor. So electric vehicle motors are all AC. In the side here, you'll actually see whereby we have another converter. And this converter takes the 400 volts from the DC and still reduces it to 12 volts and 48 volts. 12 volts mainly for most normal cars, 48 volts for the newer vehicles like the Cybertruck. And what this powers are the lights, the radio, wipers, etc. So those small things that run on the 12-volt system. I hope that's clear. Now, I've spoken in terms of a different number of voltages, and this is just something for if you're working in the e-mobility space, I think you need to understand, and that is the definition of a high voltage. If you're an electrical mechanic in terms of from the automotive sector, your low voltage, as you can see on AC, will be between 0 to 30 volts AC, and on DC it will be 0 to 60 volts. That's your low voltage. And then your high voltage will be between 30 to 1,000 volts AC and 60 to 1,500 volts DC. But if you're an electrical engineer working in the power sector, it's different. Your low voltage will be 0 to 1,000 volts AC, 0 to 1,500 volts DC. Your medium voltage range then will be 1,000 to 35,000 volts AC, 1,500 to 50,000 volts DC. I think this is important so that you don't get mixed up and you know the terms and the right terminologies to use when you're speaking to an electric vehicle mechanic or when you're speaking to a power engineer. So let's go and talk about EV battery life. Let's consider a battery with a capacity of C to start with. Over time, of course, the batteries degrade as with everything else. So typically, maybe 1 to 2% capacity loss per year. And of course, as you charge and discharge a battery, its life reduces. So when the capacity becomes, let's say, like 80% or 70%, which you are told that is when now a vehicle is coming towards its end of life. We say that you have 80% of C or 70% of C. So for like a 15 kilowatt hour battery, end of life would be 12 kilowatt hours, which is 80%, or 10.5 kilowatt hours. Then that means now those batteries can no longer be used in an EV because the range has really gone down, and now you look for other applications for them, which is the second life of the battery. Now, for our 15 kilowatt hour battery, it's charged and discharged. And so we need to be able to say that a battery is being charged at X rate or being discharged at this rate. So you can see if we say 1C, that means, and we're still talking about our 15 kilowatt hour battery, that means that battery is being charged at 1C or discharged at 1C, which means that if it's being charged, means from 0 to 100, it will take 1 hour to put in 15 kilowatts into that battery. I hope that is clear. If we say 2C, it means that it will take half the time. So 2C implies push-in or pull-out of power at twice the battery capacity, right? If a battery is 15 kilowatt hours, what we're saying is that at 2C, charging or discharging, we are putting in 30 kilowatts. And the time that will take will be half the time as well. For 4C, 60 kilowatts, time to charge and discharge 15 minutes. If you have 0.1 C rate, we're meaning what will charge or discharge in 10 hours at a rate of 1.5 kilowatts each hour. I hope that's clear. What do you think the battery prefers? Does it prefer to 4C or 0.1C? Kindly mute yourself. Thank you. Now that we understand the C rates of the batteries, let's talk about things that are affecting battery life. The first one is operating temperature. As you can see, I've written batteries love a range of temperatures, not too hot, not too cold. If you look at the graph here, you can see the place that you will get the maximum amount of cycles from the battery is when the operating temperature is just between 15 to slightly above 40. That is when the battery is the most comfortable. Earlier in the year, we saw, especially in the United States, there were freezing temperatures, and those freezing temperatures had adverse effects on those batteries, as you can see. Then you also have places that have extremely high temperatures. Those places that have extremely high temperatures will increase the degradation of the batteries. So anything beyond 40 degrees, 50 degrees, you can see how drastic the number of cycles that you can get from a battery reduces. Another factor that affects battery life is the battery chemistry. For you who let's say, like, if there's anybody who's worked on solar projects, you do know that we have those early on batteries, like the batteries that are in normal cars, called the lead acid batteries. The lead acid batteries, when you are putting up a solar system, you actually tell the client that after 3 or 4 years, you have to change these batteries. So every 3-4 years, you change these batteries. Every 3-4 years, you change these batteries. But with the coming in of lithium-ion batteries, in solar systems, you can actually give a client a battery with a guarantee of about 15 years. That's what it means in terms of battery chemistry. If you get the right battery chemistry, you can have a much longer longevity. In terms of battery chemistries that are in the lithium-ion family, there are a wide number of ranges. In your lecture last week, you had the other facilitator from Ghana speaking about the NCA batteries. But for purposes of electric mobility, electric vehicles, there are two main chemistries that are dominant right now. We have the NMC and we have the LFP. If you look at this graph here, if you look at on this side of the screen, you'll see as of 2019, the NMC was the most dominant. But under the LFP, small percentage. But in 2023, you can see that the LFP is quickly becoming the battery of choice. And if you look at these infographics, I don't know their name actually, but if you were to look at this here for the NMC, you can see that it has very nice high specific energy. That means that the power that you can put into it is much higher. If you look at the cost, not too bad. But if you look at the safety is quite low. Lifespan, not too bad. Specific power, not too bad. But if you come and you look at the LFP is the lithium iron phosphate. You can see number one, safety. Safety is highest. Cost is not too bad, but number two as well is lifespan. And I think that is one of the main reasons why, for the foreseeable future, you will continue to see the LFP being used. Hope that's clear. The number three factor that affects battery life: charging and discharging rate. I had asked a question: if you said that batteries do not like a high discharge and charging rate, you're very right. And you can see from the graph, if you're charging and discharging at 1C, you will see in terms of the number of cycles that a battery can get from it, you can see it's north of over 500. If you continue charging and discharging the same battery at 2C, you can see numbers increase. I mean, the cycles are reducing. If you charge and discharge at 3C, you can see. So this means that if you want to take care of your battery, you are advised to charge and discharge it slowly. This is also important because in terms of the charging, you might have control over it in terms of you can choose the type of charger that you want. The discharge rate mainly due to a function of how you drive, etc., etc. So if you are in Kigali and you have quite a number of hills, that means that your discharge rate will be higher as opposed to other places, other people who are on flat ground. Just something to note if when you are looking for places to pilot your electric vehicles. These are some of the things that you take into consideration. I think that actually now takes us nicely into the next part of the presentation. Electric vehicle charging modes. This is how we actually now put in power into the vehicles. There are 4 main modes. We have mode 1, which is a standard socket outlet, domestic installation. Mode 2, standard socket outlet with an AC EV supply equipment. So that is an AC EV SE supply equipment. Last week, you were told that what people colloquially call the charger is not the charger. The charger is the onboard charger that is in the vehicle. The equipment that is putting in power into the vehicle is called an EVSE, electric vehicle supply equipment. Then we have the AC EV equipment permanently connected to an AC supply network. That's the mode 3. Then mode 4, we have the DC EV supply equipment. So these are all the modes at a glance. So you can see in terms of mode 1, what we're saying, it is literally you plugging into a 3-pin socket, and then a cable goes and is plugged into the vehicle. And in that vehicle, it's basically the same kind of sockets as your appliances in your house. So you might have some with 3 pins, 3-pin holes, you know, some things that look like your kettle. Mode 1 is being phased out. There are some places that it has been outrightly banned because it is not as safe. When you will be advising your companies on the electric vehicles to buy, and a supplier comes with a charge port that looks like a socket of your, looks like a socket for your normal equipment, normal household equipments, please chase that supplier very far. They're selling you outdated technology. We have seen that happen here in Kenya. Yes, so this is just a warning to everyone else on the continent. We now then have mode 2. Mode 2 gives a maximum of between 2.3 kilowatts AC. What is important in mode 2 is this, if you can see my pointer, it is that point there. That point is sort of like regulator of sorts. On that, you can actually be able to see the amount of voltage, you're able to see the amount of current, you're able to see that, and it actually communicates with the car. So you're able to see, let's say like with the battery management system, It's able to say that the battery is 50%. Now reduce the amount of power that you're giving me. The batteries are 10%. Give me maximum power. And as you can see, that is extremely important for safety. In mode 1, there is no communication or anything. Power just goes in and goes in and goes in. Very unsafe mode. We then have the mode 3. Mode 3, as you can see, you have a point that gets into the EVSE, electric vehicle supply equipment, and you have another plug going into the car. Mode 3 is typically your AC charging. And you can go from anywhere from 3.7 kilowatts up to 20 kilowatts, 22 kilowatts AC. You then have your mode 4, which is basically your DC fast chargers. So these are the modes in a glance. I have not put mode 1 because we're never going to discuss mode 1. This is mode 2, as you can see. And in mode 2, you're able to see, in terms of the current that it gives, you're able to see those kind of parameters. Now, there is something very important that I need to stress in terms of mode 2. I have specifically chosen this type of plug-in socket because it is a safety feature. In Kenya, in the most recently announced standards by KEBS. KEBS is the Kenya Bureau of Standards. They have actually insisted that everything that is using the mode 2 have this industrial socket. This is very important because in other parts of the world, this socket can actually come in as a 3-pin plug, where it can go to your normal into your normal house socket. Now, in your kitchen, you have a cooker. That cooker has a separate wiring from the distribution board in your house. And the reason for that is the wires and everything are sized according to the amount of current that you're going to draw. What we have seen happening a lot is people going to their garages. Your garage was sized for lower equipment in terms of power rating, but people going to go and plug in their sockets, which they then charge their vehicles. That's an unsafe thing to do. If you're going to use the mode 2 type of charging, what you need to do is get an electrician, let them do separate wiring. That separate wiring will ensure that they size the cables correctly that are supplying that socket, and you can charge safely without any hindrance. But if you go and find a 3-pin normal socket in your house that is usually rated at around 12 amps, 12 to 13 amps, and you go and you put in this charger that is drawing 15 amps, you are just going to bring problems for yourself. That is very important to note. The second part here we have, this is mode 3 now. Mode 3, this is the EN+. This is a EVSC, electric vehicle supply equipment. And you can see. Then we have the mode 4. These are the DC chargers. Those things are the size of your typical fridge in your house. They're quite big. Let's talk about type of connectors. Electric vehicles are also currently facing the issues that we have in terms of iPhone users, Type-C users, etc. These are some of the plugs that we have. And the plug that you have is mainly dependent on regions. So just take a good look and we will explain further in the next slide. We now have different plugs for different regions. We have the European plug. We have the North America. No, sorry, we have plugs specific to Europe, plugs specific to North America, plugs specific to Japan, and plugs specific to China. Tesla is an outlier. They also have their own plug. In AC, which we saw was mode 2 and mode 3. In Europe, it's called the type 2. I hope you can see it. If you want to get a bit more technical, you call it the IEC 62196-2. On the AC side, in North America, we have the type 1, and that is shared so North America and Japan share the AC plug. If you want to get technical, you call it the SAE J1772. In China, we have the GBT AC. In the DC, in Europe, we have the CCS2, CCS Combo 2. CCS means Combined Charging System. In North America, we have the CCS1. In Japan, in terms of DC, we have the CHAdeMO. And in China, the DC, we have the GBT. Tesla, we'll talk about it a bit later. We also have an experimental charger that is being rolled out for extremely high voltage, extremely high power delivery called the Chaoji. It's a mixture of the Chinese and the Japan, but it has not been heavily rolled out. Going back, you can now be able to see the first one is a type 1 that is used in the US and Japan. Second one is a type 2 used in Europe, AC. Third one, if you see, it's a combined, a CCS2. You can see. Fourth one is the CHAdeMO. Fifth one, this is how our Tesla one looks like. Now, in each of these charging heads, all these pins are there and they all do a specific function. We want you to be able to understand each of them. And once you've understood one, for the most part, in all the other chargers, they're interchangeable. Just basically, literally, this does this for this one and it's put in this place. This does this for this one and it's put in this place. If you have a look at this, this is the type 1, which is this, which is this. In the type 1, we have L1. I hope you can see it. The L1 is AC single phase line 1, sorry. So that is live. We have the neutral pin. The neutral pin, that neutral is in Japan. If you're in the US, that is also line 2. You then have the protective earth. Which is this one. We then have these two other points that are the PP and the CP. I will read what the PP does and what the CP does. The PP is a proximity pilot, is a proximity detection pin that communicates with the EV's control system, allowing it to restrict movement while linked to the EVSC, and signaling the latch release button to the EV. Is that okay? That means that the lock and unlock. Once the PP has been, can someone kindly mute? Once the PP reads the signal and is engaged, that means you cannot easily just come and remove the charger and put it back in. That's for safety. You don't want people to just come and remove your charger at any point when they are charging. We also have the CP, the control pilot pin. Is a communication signal. It is used between the EV and the EVSC to communicate the charging level, initiate the charging process, and send other data. The CP directly goes and communicates with the BMS, battery management system. They have a conversation. They say that battery's at 80%. What we think now is we need to reduce the amount of power going into the battery. No. That is, so in a nutshell, these are what all those pins do. So this is the type 2 pin layout as well. And you can see in the type 2, we have the AC1, we have the AC2, we have the AC3. The type 2 can accept up to 3 phase power. There are certain plugs on the type 2 whereby they will not have the pins AC2 and the AC3. That is completely fine. They will still be able to work on single phase. As is from the previous slide, you can see you have the control pin, control pilot. You also have the proximity, you have the earth, and you have the neutral. Similar. This is the GBT. GBT is the Chinese one. And this is on DC. You have the DC positive, you have the DC negative. You have CC1, you have CC2. Which are charging connection confirmation, charging connection confirmation 2. You also have the S plus and the S negative. Charging communication. Charging communication. Similarly, these are just the charging communicators. So you can see it is not complicated at all. All they're doing is literally the same jobs. Once you understand what each pin does, that's it. This is, so just maybe asking, what standard do you think this is? If you guess that it's the CCS1, you'd be correct. This is the charging standard that is actually used in the US. And you can see DC, we have DC negative, we have DC positive, there's a pin. Protective earth, 1 pin. Contact 5, looking at proximity detection. Contact 4, communication. Contact 2, AC level 1 neutral, AC level 2 power. Contact 1, AC level 1 power, AC level 2 power. Same thing. Now let's talk about Tesla. Tesla is strange in that the AC connector is exactly the same thing that they use for the DC connector. You can see these are the pins. So one of them is a DC positive, which is L1, DC negative L2. I know now you know what PP is and what CP is. Ground is earth. This is the type 1 connector. No, this is the CCS1 connector. And you can see the difference in size as compared to Tesla. So these are just sample chargers. At EV Charger, that's one of our charging points. This is a mode 3 AC charger, 22 kilowatts. We've connected it on 3-phase. There's something here that's very interesting. If you have a look at this, we have this point here. EV Charger, we ensure that we are able to service 2 types of vehicles. Kindly mute. So our connectors are able to service the European vehicles and the North American and Japanese. So our cable, which is this.
Please, I can't see from your screen.
You're not seeing us, you can't see.
I cannot see your screen.
What are you seeing?
Nothing in displaying.
It is displaying sample charges.
It is displaying sample charges. You can see, right?
Yes, maybe it's a network.
Or maybe it's apologies, you might be having a network issue. Maybe just try and log out and then log back in. So what EV Charger does is that we try and the cable is a type 2 to type 2. We have these things here, if you can see, that is an adapter. Now that adapter is a type 2 to type 1. I'll repeat. We have cables that serve type 2 to type 2. That means that if your vehicle is from Europe, you will be able to come and charge at our charging point. We also have an adapter that will be able to serve cars in AC that are from Japan or North America. That means that currently, if you have to go to our charging points with a Chinese vehicle, a Tesla, you might have a challenge. This is important because if for some reason let me go back. Let me first of all take a step back and discuss where it is that we get our vehicles from. East Africa mainly gets its imported vehicles from Japan. So the Toyotas, etc. So we do have the plug-in hybrids. The plug-in hybrids mainly have the type 1 from Japan, and on DC they have the Chademo. From Gad's presentation, I'm sure he mentioned that Japan still believe that electric vehicles would happen. So we do not expect them to be exporting a lot of used EVs into Africa. So for the Kenyan market specifically, we then reason that the place that we will get a number of our used electric vehicles from will be the UK. The UK now use the Type 2, and in DC they use the CCS2. That is why if you come here, you can see that we have put the cable as a Type 2 to Type 2. The reason is that in future we expect that majority of the vehicles coming to Kenya because Kenya is a right-hand drive, majority of those vehicles will come from the UK. On this photo as well, in terms of the charger, we have put the charging cables. Charging cables are, as you can see, the charger is this small thing here. Not the charger, sorry, the EVSC, electric vehicle supply equipment. The charger is inside the car, but the electric vehicle supply equipment is this small thing here. In developed economies, as a charging station, what we are supposed to actually put is just the EVSC alone. The cable and everything else, the client should be able to come with it. But this being a new concept in Africa, it becomes very difficult for you to expect someone who's bought a used EV to be able to then now tell them to start looking for charging cables and all these other things. So currently what we're doing is that we're giving up this whole setup, but it is important to know that ideally that is not what should be happening. If you look at on the second photo, this is the size of a DC charger. Now, these are adapters, and these adapters this is the adapter, and this is how it looks like. You have small adapters. All these adapters are currently for AC chargers. So you can have adapters that can go generally across all this. So you can have an adapter that adapts from the type 2 to the type 1. You can have an adapter that adapts from the type 1 to the type 2, depending on your vehicle. You can have an adapter that adapts from type 1 to GBT, or an adapter that adapts from type 2 to GBT. Recently in our company, we just sent a few over to Ethiopia that are adapting from the type 2 to the GBT. I'll go back to this photo here. So for East Africa and Kenya in particular, where we're going to get our cars from is a very straightforward thing. In terms of electric vehicles, our right-hand drive will get majority of our vehicles from the UK. But let's say you go to Ghana or Nigeria. Ghana and Nigeria some of them get vehicles from North America. Some people will get vehicles from Japan. Other people will get vehicles from China. And other people will get vehicles from the EU. I want you to picture if EV Charger was to go and open up in Ghana or Nigeria, the kind of challenges that we would be able to have satisfying that market. This is one charger where at this point in time, we're able to supply 2 types of vehicles. What if in Ghana, whereby we know that there are a number of people who bring in Teslas from the US, who might bring a Ford Mach-E from the US. What then happens to those people? As a person who's in the charging business, am I expected to be able to cater for all those type of vehicles? Am I expected to be able to give this kind of chargers? And let's say like I have 1,000 chargers. Currently, I just need to buy one for the adapting of the type 2 to the type 1. But if I have 1,000 charging stations, am I expected to be able to now adapt for North America, adapt for China? It becomes quite a cost. It becomes quite a challenge. So in Kenya, as an industry, without waiting for regulatory oversight, we are encouraging people to go the CCS2 route. That is what we are doing here in Kenya. It may change, it may not change. We will see in the future, but that is what we're currently doing in Kenya. And you can see why it is important to have one type of standard. If you are importing, so Kenya is a hub in terms of a lot of importation of vehicles. So let's say like in Kenya, you have one standard. And then our neighbors whom are landlocked, either Uganda or all these other places, have a different standard. That means that without having an adapter, you will have to carry that vehicle on a flatbed up to the point that it gets into this other country. So that's when now you'll be able to charge it. Having a single standard will greatly help us. So let's talk about kilowatt and kilowatt hour. Let's say you have a vehicle that is 50 kilowatts. 50 kilowatts. Kilowatts measure power. The higher the number of kilowatts offered by a charging station, the faster it will charge the EV, provided that the EV's onboard charger can support that rate of charge. We then have the kilowatt hours, which measures battery capacity. So every EV has a maximum kilowatt hour rating, which represents the maximum amount of energy it can store in its battery. So the larger the kilowatt hour, the greater the EV's driving range will be. So from the beginning where we had the 15 kilowatt hour car, you'll find that that has a much smaller range as opposed to a Tesla, which has about 89 kilowatt hours. So if you have a charger, an AC charger, or a DC charger actually, that is rated at 50 kilowatts. That means that it can give out power at 50 kilowatts, right? And you have a car that has a capacity of 100 kilowatt hours. This means that its quote unquote fuel tank is 100 kilowatt hours. In theory, what this means kilowatts each hour. And for you to be able to fill up this 100 kilowatt hours, you will take 2 hours. This is important when you are calculating charging times. So if a supplier comes to your company, they tell you that we'll put for you a 7 kilowatt charger AC, or a 22 kilowatt charger AC, you will be able to, with the size of the battery of your car, be able to say that, I think this will take 4 hours to charge, this will take 5 hours to charge. I hope that is clear. So, and then finally, this is just a schematic. This is an EV charger. This is a charging point that we are going to put up. And this is basically everything that someone needs to have a look at when they're going to go and install a charger. Number one, you need to go and look at the transformer. You need to go and be able to look at the transform. And so this thing will be divided into 2 parts. In Kenya, from the transformer all the way up to the meter, that is property of the utility, which is Kenya Power. So if I want to, like when we were installing this particular charger, it is the Kenya Power engineers who actually helped us with information upstream, this side. Very important to know. So what did the Kenya Power engineers look at? They looked at the size of the transformer. And in the size of the transformer, what you're looking for is, if I'm able to put in this new load, which is my EV charger, will we stress the transformer? Will we start bringing blackouts? So we're looking at the capacity of the transformer. Then, the client, this particular client, wanted one charger. But he actually asked us to also tell him, if I want to put, if I want to future-proof and later on be able to put in 2 chargers, what would it require, or what would it mean? You can see currently in terms of the existing cable, we said that with the existing cable or with one charger, you will be very okay, there'll be no problem. But if you put in a second charger, the Kenya Power engineer came and told us that you will need to do an upgrade. So you will need to upgrade the cable from the transformer to the meter. I am walking you through the process of installing a charger so that you just have, you can appreciate you can just appreciate it. So that is on the Kenya Power side. Now, from the meter all the way to the charger, that is basically EV charger side. Our engineers are the ones who handle that. And that is, basic, basic wiring in terms of being able to size the correct wires. If the distance is, say, 100 meters, being able to calculate the voltage drops so that you ensure the right voltage gets to the charger. That is pretty much it. Thank you very much. I think we can now take questions. Gad, are you there?
Yes, John, I'm here.
Fantastic. So I think we will want to go through the okay. I can just.
So
I'm starting.
I think there's Q&A. Faith is here, so she can help with the. Then after she move to the second part of the session quickly.
Q&A, Gad.
Yes, yes. You want me to read the questions for you? So please, if you have a question, you can type it or you can raise your hand. There's a hand raising feature. If you look at your screen, the top right, all the things you see like a hand, you can click on it, and that will give you the opportunity to talk. So, okay. Your question. Somebody is asking us, Queen Star Atieno Otieno. Wow, very psychedelic name. About the most of charging. That is 1, 2, 3. Charge from front, side, and four from behind. Are all EV vehicles designed that way? Or it depends on the make of the vehicle? I think she's talking about the ports, the location of the ports of the vehicles, whether it's manufacturer dependent or not.
Yes. Yes. So the port is for the old cars like the Nissan Leaf, the ports are at the front. We have an electric vehicle in our company. The port is actually on the side. In fact, it is exactly where where you'd expect to get the fuel tank. So that is not dependent on anything. It can be on either side, from the front, back. Some even have them at just after the front tire. So there is no law governing where it is you can put them. You will find them in all different places. Okay, Gad, next question.
Okay. Are the charging stations manned or is it self-service? How are payments?
I can see we have entrepreneurs in the room. So EV charger, we do have our own application. So if you want to use our charging points, you can download our app. I encourage you to actually download it now. Have a look at it and you'll see. From the app itself, you'll be able to see that you are able to see and tell where our charging points are. You are able to actually choose the amount of power that you require in terms of time. You then are prompted to make a payment on M-Pesa. We do have a wallet. So before you actually charge your vehicle, you need to pay. You need to have some money in the wallet. The app will calculate what it is that you require to use. You choose the time. So let's say, like, if you want to charge for 30 minutes, it will actually tell you that in 30 minutes you will be charged X amount of money. And that money needs to be in your wallet, which is supposed to be prepaid. If you have that money, you just press start charging. It will continue charging. If for and it's very automatic. After 2 hours, if you've chosen for 30 minutes, Once it reaches 30 minutes, it will automatically disconnect itself. I think I've answered that question, Eunice. Next question. Any other question?
John, there are more questions at the chat.
Okay. Okay, let me have a look. Okay. Lina Tis has asked, since slow charging is recommended, is it advisable to charge at 1C or 0.5C? Does this affect charging costs? What is the charging cost in Kenya? Lynn, I will answer part of your questions. The other ones, now you'll have to come to EV Charge and then we can discuss. Slow charging is always recommended. The slower you charge, the better for your batteries. Even for solar systems, whenever you're designing a solar system, you try and design, so it now becomes a cost issue. You try and design whereby the battery it's called trickle charging, puts in a small amount of power over a long period of time. And when you do that, you find that your batteries will last much longer. Most especially for the Nissan Leafs, the old Nissan Leafs that did not have proper cooling. Frequent usage of DC chargers may have some adverse effects in terms of battery life. It is recommended that you use AC charging for most of your charging. Lynn, for the rest of your questions, shoot me an email. We'd be happy to discuss in terms of costs for charging and things like that. Our charging stations, we do have charging stations at Waterfront, AdLife, and this is we have the audience is not just made up of people from Kenya. There are people from other countries. So I'll just quickly say it. We have a charging point at AdLife. We have a charging point in Two Rivers. We have a charging point in Nakuru, Westside Mall. We have a charging point in Kisumu, Mega City Mall, and a charging point in City Mall in Nyali. Okay, next question. What factors affect the speed of EV charging? EV charging is affected by the rate at which power can be accepted by an EV. Number one is affected by the amount of power that is in the battery. So, and I think this was actually covered last week. In a battery, if a battery is at 10%, it is able to take in more power than a battery at 90%. So you'll find charging manufacturers will always quote the 20 to 80%. They'll always tell you that this charger, or even vehicles, that this vehicle can take, can charge from 20 to 80% in about 30 minutes. And the reason for that is because this is the point in time that the charging speed is the highest. So you'll find between 20 and 80%, it might take you 30 minutes. But then between 80 to 100 might still take you the same 30 minutes. So the amount of power that is actually, the amount of energy that is actually in the battery is one of the factors that affect the charging speed. Another factor that affects the charging speed is just the rate of the charger, the rating of the charger. If you have an AC charger that is rated 7 kilowatts, and you have another charger that is rated 11 kilowatts, and you have two identical vehicles, all of them, all factors remain constant, the one that has 11 kilowatts will charge it faster than the one with 7 kilowatts. But there's a caveat to this, which actually now goes to the point number 3, that another thing that actually affects charging speed, the rate of the onboard chargers. The old Nissan Leafs had a maximum of, had an onboard charger rating of about 3.3 kilowatts. That means rated at 22 kilowatts, the vehicle is only at the maximum able to take 3.3 kilowatts. Majority of electric vehicles like our company car can take 7 kilowatts. So that means even if the charger is 22 kilowatts, even if the charger is 11 kilowatts, our car will take 7 kilowatts. High-end cars actually reach 11 kilowatt hours, 11 kilowatts. And so those are the factors that are actually affecting EV charging. Prudence has asked about Ethiopia has banned the use of ICE vehicles, both new and used. Does this give Ethiopians the time to seamlessly transition from ICE to EVs? Also, which type of EVs are they using? There are reasons why Ethiopia banned. So what Ethiopia is saying is that they have not removed the cars that are on the road. So all the ICE cars that are still on the road, ICE cars are, God said, these internal combustion engine cars, those ones will still remain on the road. What they're saying is that if you want to bring in any more new cars into the country, it has to be electric for passengers. The main reason that this was done in Ethiopia's case was the lack of the US dollars that is in that country. In my presentation, I spoke about Kenya. Kenya uses 500 million US dollars a month. That $500 million, you are just waving to them, bye-bye. They will never come back to your shores. By Ethiopia taking this bold step, we will wait and see in terms of the numbers, but we will see what kind of decrease that will have in terms of their foreign, or in terms of the dollars leaving their shores. If you read, we've read a couple of articles, we've spoken to a number of people in Ethiopia, most especially even in the government, and this was one of the main reasons they did what they did. Now, Ethiopia, just to answer your second part of your question, the main vehicles that are making it into the Ethiopian market are second-hand electric vehicles from China. So you do have a number of the Chinese brands, you have a number of the European brands. Please, can we charge the battery of the car? Or Jennifer Mawufemo. Please, can we charge the battery of the car, or is it inbuilt? I think you are talking about swaps. So for most four-wheeler electric vehicles, you will find that the battery is inbuilt and you cannot remove the battery. For motorbikes, it is not the case. There are some motorbikes that you can actually go and remove the battery, and they do have swap stations. Should EV charging stations be regulated like gas stations? Fair pricing and accessibility. Amina, I don't, but I can see and I can tell that you're probably from a regulator. And for now, as this industry is taking root on the continent, and we actually did discuss this sometime last year. We had a panel which had EPRA is the regulator in Kenya. There was a regulator from Zambia, and I think a regulator from Ghana as well. And this question came up. The regulator from EPRA said that currently we have no plans to be able to regulate it as of yet. And the main reason for that is they do not understand the costs yet associated with them. And so they need to be able to, first of all, let the market grow, and then if it in terms of regulation, that can be done later. So for me, I still think that regulation needs to first hold off a bit, let the market grow, let competition come. As EV charger, you cannot charge, or whatever it is that you're going to charge, we have competitors. And so we let the customers actually be able to choose. I cannot go and exploit the customer. If the customer feels exploited, they will definitely go to my competition, and vice versa. So I think for now, let's just let market forces play. Do you make home charging installations? Yes, Eunice, we actually have installed a number of chargers for Eunice. Okay, we were discussing charging. Some of your questions are a bit more on the EV charger side. Not really relevant here. You have my email address. Please reach out to me and I will answer all those questions that are pertaining directly to EV charger. So please, can you replace the battery of the car? Yes. In the first slide, as we started, I will just allow me to share my screen again. Allow me to share my screen again. I hope you can see my screen. So this was the technical training that was carried out early this year at Rome. And you can see here, this is the battery pack for the Nissan Leaf. Anything that is in orange is high voltage lines. And these are things that that you are told about in lesson 2. But you can see we have removed this battery pack. We can easily just as well get another battery pack and put it back into the car. So it is very possible to be able to remove a battery pack. It is actually possible. If you can see these photos, these are called sardine cans and they're modules. So if remembering from last week's lessons, you have cells which make up a module. Then the modules make up the battery pack, right? So you're able to even change modules that are spoiled. So if you find a module is bad, you are able to take it out, get another module that is actually good, and put it back in. So it's very possible to do that. For hybrid vehicles, is there, so sorry, this is our next question from Aska. For hybrid vehicles, is there battery inbuilt or do they charge like others? So for the hybrid, we have different types of hybrids. All the hybrids, the battery is inbuilt inside the car. But there are hybrids that are charged by there are hybrids that are charged by, as the engine is moving, it is charging the battery. There are hybrids that are the plug-in hybrids. Now, those plug-in hybrids have larger batteries, and those ones can be charged by our charging stations. So that's the difference in terms of the hybrids. You do have hybrids that they are the mild hybrids, which usually have smaller batteries, some even about 3 kilowatts. Then you have the plug-in hybrids like the Outlander, PEV, that have battery sizes of about 11.3 kilowatt hours and 13, and in the newer versions, 13.5 kilowatt hours. I hope I've answered that question. Eunice is asking, when there's power blackout, do the charging stations work? So there are charging stations that do have batteries, and that is very, very new technology. In fact, it is being, I think it has only been deployed in the US and Europe. But for the most part, most charging points do not have a battery backup system inbuilt. And like for us, most of our charging points are in malls, and that means that the malls have generators. I hope that answers your question, Eunice. Margaret, with the recommended slow rate of charging, high number of waiting vehicles in line and smaller size of transformers, how are companies? Okay, Margaret, with the recommended slow rate of charging, comma, high number of waiting vehicles in line and smaller size of transformers, how are companies addressing this? I guess what you're trying to ask is if you have one charger and let's say like 2 or 3 cars come. Currently, the market is still very small. We do have data and we can see our busiest locations. Now, those busiest locations, what will happen is that we will then be able to put in another charger there. Now with the data. So if a location is extremely busy and we, from our clients, and we hear about it, we'll be able to put in another charger and another charger and another charger there. So we'll put up the chargers based on demand. For your part of the transformers, that is a hard question because that is really not in our, that is on the Kenya Power side, and that is the utility. So be it in Ghana or Nigeria, I do not know the processes there, but I suspect that it is similar. And that is actually based on the utility. If we want to put up a charging point and the transformer is smaller or it has a low capacity, we bear the cost of putting up the transformer. There's Sylvia, in reference to Ethiopia, do they have enough charging stations set up for transition? Not sure about that. Lynn, are there challenges associated with cybersecurity? This is based on the charging modes and the pins that allow for data communication. Yes, our company, we do have a data protection policy. And we do have a data protection policy. And based off the vendors, and your question is actually very good. It is important to have the right type of equipment. The right type of equipment ensures that you're not susceptible to malware and all those other funny actors. Blessed has asked, as more African countries are currently in the transition phase to electric vehicles, are there recommendations of best electric vehicles and battery brands? It seems we're really focusing more on charging. Blessed, yes, this is an introduction to charging class. I think that's why we are mainly focusing on charging. In terms of brands,
wait, what was the question? Was the question what's the question?
As most African countries are currently in the transitioning phase to electric vehicles, are there recommendations of best electric vehicles and battery brands? It seems we are really focusing more on
no. That is, if I will say, the premise of the question is wrong. Okay, I think before the year is out, we'll be doing some small, what we call an EV buyer's guide that anybody can read. But ultimately, it will depend on the usage case and some peculiarities that have to do with where you are. Okay, so if you are buying a car for an EV as a second car for your city usage, it's different from if you are buying the EV as a primary car or if you are buying the EV as a commercial vehicle. So there are nuances to that, and also your environment, and even your maintenance culture. These are things that play a role, and your pocket also. It plays a role on what EVs may be suitable for you, because a brand that may be best today for you tomorrow may not be, because the industry is now growing and maturing and also changing very fast. I hope that answers the question. So John, please continue.
Olayemi Dixon. I thought this is supposed to be an all-female, but I think might be using someone else's account. How many hours does it take to charge an electric vehicle, and how many hours can the battery last? Olayemi, in our slide, I will just kindly share my screen again. This slide, I hope my screen, I hope you can see my screen.
It's clear, you can see it.
Fantastic. So, the charging time is dependent on the rating of the charger, the onboard charger, what is the maximum amount of power that the car can take, and the size of the battery. Those three things. So this example of ours here, the battery size is 100 kilowatt hour. That's the size of the battery of this car. The charger is 50 kilowatts. That's the rating of the charger. That means that in 1 hour, it can give a maximum of 50 kilowatts. And the onboard charger has a rating that can take 50 kilowatts or above. With all these conditions, it then means that the vehicle, for you to fully charge 100 kilowatt hours, it will take you 2 hours. Because in each hour, you're putting in 50 kilowatts. So hour 1, 50 kilowatts, hour 2, 50 kilowatts. And so then the charging time for that vehicle will be 2 hours. Yeah, I hope that is clear.
Very well, sir. The reason why I asked this question is that in the last class, that was last week Thursday, the presenter said it takes like 30 minutes to 1 hour for an electric vehicle to be fully charged. So I didn't get that clearly. So that was why I had to ask again to be very, very sure. Thank you for the clarification, sir.
Thank you for the feedback. Is there any other?
Dorcas has raised her hand. Dorcas has raised her hand.
Yeah, Dorcas, kindly go ahead. Dorcas, the floor is yours. Kindly go ahead. Dorcas, we cannot get you. If you're trying to speak, I think you're muted. I think we've lost Dorcas. Are there any other questions? When silence, I hope it means that you have all understood and I am the best teacher in the world.
I think maybe you are the worst.
Fantastic. I really, so now just to, if there are no more questions on charging, I will just, before I leave, we actually are in the process of, we have the Africa E-Mobility Week that is currently going on in Nairobi. And so let me start again. African NEV and everyone that you have seen are extremely, extremely passionate about e-mobility. I have explained why. And I'll reiterate this. And I want everyone to just, in your own countries, to go and have a look at these statistics. Kenya uses 500 million US dollars. Mercy Yogo, you've raised your hand. Kindly just go ahead.
Can you hear me?
Yes, we can.
Thank you for the opportunity. My question was concerning batteries on, especially the lithium. There's always that bit of fatal consequences when it comes to fire. So my question is, what are the recent developments in regards with the research on the battery size and the safety bit about it? That's my question. Thank you.
Fantastic. I will share my screen again. Just a minute. Share. Can you see my screen?
Yes, I can see it.
Fantastic. So,
Yes.
okay. If you look at this, and most especially here in 2019, the major chemistry that was being used in terms of electric vehicles was NMC. I'm sorry, let me just remove this. And you can see in terms of the NMC, it had a lower safety rating. I hope this is clear. You can see. The LFP is a newer technology, newer chemistry. And you can see from 2019, it had a very small percentage. But mainly due to its excellent safety rating, there is actually a video on YouTube. You will literally see the BYD guys drilling through the batteries. And they drill through the batteries and nothing happens. That was done to show people that these batteries are safer. And the chemistry that they are using is the LFP. And you can see now from 2019 now to the 2023, it is increasing. So that means that the industry is changing and shifting towards a more safer chemistry. It might have less, it might give you less in terms of performance, but the safety aspect, I think, is key. And that is why you can see a lot of the industry is shifting towards that. And something else that I think you need to note, this is between 2019 and 2023. That is how dynamic things are in the EV space. Things change very quickly. So you will find that you need to be constantly reading, constantly updating yourself. I hope that is clear.
Yes, it's clear.
Fantastic. Any more questions regarding the presentation? Okay, so I think I'll summarize right now. Kenya uses 500 million US dollars a month to import fuel. I want all of us in our different countries to just go and have a look at how many dollars do we use on a monthly basis or a yearly basis that we send to wherever it is that we are sending. And just picture what that money would be able to do for our economies if it was used to strengthen our grids. There was a question that was asking in terms of the transformers. In my slide, in one of the first slides that I shared, there was a statement that says that 90% of Kenya Power's revenue comes from 10,000 customers. And out of these 10,000 customers, majority of them are then now moving to self-generation. So you are Kenya Power. You earn, let's say, like $10 million a month. And out of this $10 million a month, $9 million is coming from 10,000 customers. And you have more than 7 million customers. And out of these 10,000 customers, they are all now, some are going to solar, some are going to wind, some are going to biomass. So this $9 million that you are earning is going at a it is depleting at a very high rate. I want you to try and picture what will happen to majority of us, because there are 10,000 guys who are the large industries. And then there's the 6 plus million of us who use power for everyday use. Right now, power in my house, we have the very small businesses like barbers, ladies who sew, sewing machines and things like that. Those guys cannot go and afford a solar system or anything like that to be able to handle their needs. It is imperative that for our grids to be able to survive, it is imperative that we stimulate demand. This is a national crisis, in my opinion, in the making. It is imperative that we are able to stimulate demand, and that stimulation of demand means our public sector vehicles, we transition them to electric. Everything else we transition to electric. For the houses and everyone that can, we transition our cooking to electric. That then gives us enough demand to be able to sort out the whole grid in its entirety. The video that I advise you guys to watch showed the generation, transmission, and the distribution. All those things need money for us to be able to live better lives. What will happen if we do not have enough demand to our small business people here? More blackouts, more unreliability on the grid, and it's a spiral that just keeps spiraling like that. You can see, and this is a similar problem, I think, across the whole continent. If Kenya Power continues getting into more problems, that means the transformers or anything else will have problems, and I will not be able to. They will not be able to service me. But if they know that electric vehicles are coming, they are then able to now budget and say, now there is money that is going to come for us to be able to do X, Y, Z. As e-mobility is continuing, I would just like to urge you guys to please be on the lookout. You've taken a very good first step into entering a very new and exciting industry. My hope is that you make the best out of these opportunities. I will leave you with one story that I always tell everyone that I speak to in the industry. In Kenya, there's a company called Rome, and Rome lost one of its female engineers. This particular female engineer studied at a vocational training institute in Kenya. For the people who are in Kenya, she studied in Kabete. So she studied in Kabete, worked at Rome for 4 years. She is now currently at Tesla. Direct. You understand? Those are the kind of opportunities that are there in this space. Thank you for being a very attentive audience. I hope to meet people in the space. I hope to meet you as well in the industry. Mary, you have a question? You've raised your hand.
Yes, please. You mentioned something about the African, what is it called? The event that is taking place in Kenya right now. Would you give more details, please? Yeah.
Okay. So I am actually on my way there. There has been events for the last 3 days, the Africa E-Mobility Week that was happening at Sarit Center. It is a paid event. Africa NEV also has its own program that we are actually planning for. And follow us on our socials, especially Faith Waraki. She will give more details on that. And I know that is for the Kenyan edition. Gad will actually speak more on something else that is happening in Ghana. So kindly just follow us on our socials. Around November, something will be happening at Waterfront. The date, it's around November 23rd. Yeah, we're still working on it. Any more questions? I think I'll now hand it over to Faith. Thank you.
Thank you, John. And I am grateful to be here with the ladies. I would say I concur with you that there is a lot happening in the space. And if these ladies will follow us on the social media pages and especially at the LinkedIn, our professional profiles and the others that we will share over time in these platforms, they will be able to be upbeat on what is happening and also the possibilities that are there to continue partnering with AfricaNev in these trainings and many more. So before we end the session, I request that the ladies will be able to check. There is a requirement. I will need to lead it. There's a requirement. There's a requirement that will be shared. For you to receive your certification, you will need to have filled a certain form. There is a certain form that will be sent into your Google emails or into your emails. It's a Google document that has the EVTT assessment questions. So you will need to fill that questionnaire. It's a very, very simple questionnaire. It has the first question. You need to put your email, you put your name, your first name and your last name, you put your gender, you put your education, your highest educational level attained, you put your phone number, you put your country of nationality, you put your profession, your organization, and then you put your title. You put the title. If you're a student, you can put your learning institution, and then if you're a student, you put a student. Then why do you want to participate in this training? You will put the details there, then you will submit. Immediately you submit, you are going to get a confirmation. And that confirmation will be, first, you'll get a confirmation saying, thank you for your interest in the sponsored all-female EVTT program by AfricaNev. We will communicate further details to you in due course. Then after that, you are going to get another email coming into your inbox. I'm just trying to read that email, please. Saying AFC1, AfricaNev1, EVTT assessment questions for Cohort 1 of the all-female electric vehicle training, technical training program. Please, this together with your participation in previous sessions are requirements for your certification. So please look out for all those requirements so that your certificates will be ready and we will be able to have them issued in accordance to the requirements that are stated there. The other thing is that I know the notes are being shared and the audios and the YouTube links, but participating in the session, being in the session is very, very, very key. It's very, very, very key. So I think that's all I have, unless Gad has something else to add on top of that.
Thank you very much, Faith. Can you hear me clearly?
Yes, we can hear you.
Okay. So this brings an end to sessions EVTT. Like Kate was saying, there is an assessment that you have to, some questions, simple questions that you have to go through. We want to see how well you understand and remember some of the things you are supposed to remember. However, dropping in the WhatsApp group right now a form. It's a simple form that we want you to fill that will help us to assess the session so far. We have made some observations from this cohort. We did observe that a lot of you had internet. There was timing challenges as well as internet challenges. So, for example, the first session, at the maximum number of people was around 125 or so. But when we checked the attendance records, we discovered that actually 250 different people joined the session. Today, I think the maximum was 68 or 70 or so. But I am sure, based on that feedback, that we will have way more than that, multiples of that, who have joined the session. That suggests that people were joining. Oh, okay, my network is unstable. All right, let me turn off my video, so that will help. That suggests that people were joining and leaving for one reason or another. So please, let me show you how the form looks like. Maybe let's see. Please, can you see my screen?
Not yet. Okay,
Yes.
Yes, we can see your screen.
So when you go to the group, I will actually mail it to everybody, like the other materials, together with the notes for today. Please, just fill it. It's a very simple form. 4 sections. One, this general page is about the program itself, how you heard about the program and whatnot. Then you have, wait, is it the form? Oh, okay. No. Please, this is something else. This is the wrong form. Wait, you filled the wrong form, eh? This is a feedback form.
I shared what you. I filled the one that you sent me. Maybe you could be shared.
Yeah, I think that's the wrong form. So maybe.
Okay. Okay.
So yeah, that's the wrong form. That's the wrong form.
Yeah.
So this is actually the
Maybe
form.
delete
This is actually the form. Yes, please delete it. Let me share the actual form right now on the group so that they can do it. Good. So this is the form. It's a very simple form. Once you fill it, we'll be very grateful for your feedback on the training. So there's a part on yourself, how you heard about the program. There's a part on the first session. I know that some of you were not able to join live, but you were able to watch. Your feedback on the first session is basically number one, the facilitator, and then the session itself. What do you like about the session? What do you feel that we can change about the session? What do you feel you can add to the session? And what do you think you can remove from the session? Okay, so you have that for the day 1 session, day 2 session, and then today's session, which is the last day. Very, very important. Now, secondly, your group, which is a Friday group. Please, Mary Minor, please mute yourself. Mary Minor, please mute yourself. So, your WhatsApp group, by this evening, we'll share the link to the Friday group. so that you all migrate from that group to the Friday group. We will collapse this group, and then you have a combined group for cohort 1. This is AFC cohort AFC1. That is all female cohort 1, so that you can all have one WhatsApp group for things that you have in common. Thirdly, the assessments. We want to, instead of doing it today, after tomorrow's session, when the Friday people, we will then share the assessment links for all of us to participate. After that, we will look at the attendance records as well as the assessment. Now issue the certificates. So you'll be getting certificates in due course. Fourthly, concerning this program, after tomorrow, we'll announce the next a call for the next cohort. Some of the people who applied, even though they qualified, they couldn't be admitted into the program. And I think that some of the people who were actually supposed to be part of this cohort, some didn't turn up for one reason or another. So the call will be made open. If for those who are not able to attend at all, they can draw our attention and then we can add them to that call. However, that program will happen in the first quarter of next year. The dates and the details will be communicated together with the call, like we saw for this one. The call came with when the program will start and when the program will end. Then the fifth point has to do with the physical components of this training. This training is the online part of the technical training, which includes a physical training for 5 days where we spend time with the vehicles. We are still looking for partners to help us with funding for the physical training, because that one involves way more financial outlay. So who is that? Somebody is so if and when we get the funding, what will happen is that it will be on a country by country basis. Messi, do you have Messi? You go. Do you have a question? Well, your hands are raised.
No.
Okay.
Sorry, I think I just touched. Sorry, I don't have a question. Thank you.
Okay, no problem. So on a country by country basis, what we will be doing will be having the physical trainings. For your cohort, for example, the maximum number of trainees are from Kenya, Ghana, and Zambia in that order. So if they are going to be physical trainings, then when the physical training starts, Ghana, Zambia, and Kenya. That is a very important point to note. So when that is happening, what you see is that you will get emails, especially those who qualify for the certification. You will get emails informing you about the training. Now, having said that, let me share my screen again. The EVTT program, before the year ends, is happening in 2 countries. This is the paid program. Okay. It's happening in Zambia, and it's happening in Ghana. In Zambia, it's happening in Solwezi and Lusaka. The cost is 7,500 kwacha, Zambian kwacha. But there's an early payment discount, so you pay 6,500 Zambian kwacha. You can use a QR code to scan for that. Now, the reason why this is important is that we may get some support. If you get some support for some of you who came for this training, then we can add some of those people to some of the ladies from Zambia, the Zambian training. Okay, so maybe they have funding for 10 people, whichever is the situation, 10 ladies. Okay, so all the ladies from Zambia, we select 10 based on an agreed criteria to join the cohort. So you will not pay. So that's happening in Zambia, in Solwezi, 21st to 27th October. So the virtual part, for example, you have already taken part in it, so you don't necessarily have to come. Please, I'm not saying that it is guaranteed. I'm saying that these are possibilities. Then we also have Lusaka. Lusaka will happen before Solwezi, which is from the 11th to the 18th of October. Now, my country, Ghana. So, where is it? Ghana. For Ghana, it is happening in November, from the 15th to 2nd of November at the Ghana Automotive Development Center. That is the former mechanical Lloyd for the Ghanaians who are here. It's around Circle, just by the STC yard. We are also talking to some funders to see if we can get support for you, the ladies from Ghana who qualify for that to be included in the program. However, all of you are also coming from, most of you are coming from institutions. Some people have already reached out to me that they want their organization to sponsor them for one of these paid. If you have that desire, you can reach out to us and we will write appropriately to your organization. You'll be very soon receiving, I'm sure before the week is out, an email from African EV with a generic letter addressed to organizations that you can inform them about these trainings, that you can forward to them, so that they can register you and can then pay for you. If you are not, let's say you want to come for the Ghana training and you are not from Ghana, you have to pay $350. If you are, let's say, you want to do it in Zambia, and you're not from Zambia, you pay $350. And that does not include your accommodation and transport to the venue of the training. Obviously, during the program, it includes your feeding. 5 days, and you throughout the hello, can you hear me? Hello?
Yes, we can
We can hear you, guys.
Hello? Hello?
Hello. Yes, we can hear you.
Okay.
Hello, we
Okay,
can
okay.
hear you.
So, okay. So the program is the idea is very simple when it was conceived, which is you have an electric vehicle and we do a tear down of the vehicle. What you have gone through
We've lost you. We've lost you, God. Hello.
And then I'll put them back together. And when you do that, when you put them back together, the car must work. That is the actual pass mark for that training. Of course,
Excuse me, we lost you, so you can start from where we lost you.
Okay, where did you lose me?
Where you are saying like you're not coming from that country, you're supposed to pay some dollars that does not include accommodation.
Okay. So I'm saying that the cost of the training, is $350. All right. However, we have for the particular host country, we try to give the local currency equivalent, sort of. All right. So if you are going for any of these trainings and the country you are going for the training is not your country of residence, which that you'll be paying from a different country, then you pay $350. Okay. And that $350 caters for the cost of the training. It does not include your transportation to or flight ticket or whatever from wherever you are to the venue for the training or where you will stay whilst coming for the training at location. That is the first point. My internet is just misbehaving. So the second point I was going to make is that the training itself, we design it in 2017 to be a hands-on training. So even if you're not a technical person, there's a card before you. Then under instructions, you take the card apart to its component, look at the component, study it. Then at the end of the day, you have to put the car back together as a group. And when you do that, the car must work. If the car does not work, you have not passed. This is very, very important because after this, no matter who you are, nothing about this product should be able to confuse you. Okay. Right now, you are far more knowledgeable than I may say 90% of the people in your countries when it comes to electric mobility. But that will also take you to the next step. Of course, if you are a mechanic and you come for that training, then you can now begin to do what we call replacement kind of maintenance, basic diagnosis and replacement. There is a more detailed training that is way more technical. That one is meant for only very technical people, which will start rolling out. has been quite excited. There are also more female-focused activities that will be coming up. So, for example, next year, at least there will be 2 female-focused panels when it comes to our webinars. We have monthly webinars that we have. This month, because of this program, it seems we are taking a lot of our attention from that. So expect that. And then also next year, it's likely we'll be having the Sustainable Energy and Transport Summit. At African EV, our activities aim at driving electric vehicle adoption in an accelerated manner falls under a number of areas. We have our capacity building and skill development activities, which we call the EVTT programs. Then we have the policy advocacy, networking, and ecosystem building activities. Those involve our any program you have come to so far. It has various elements and legs to it. So if you want to participate as an organization, you want to exhibit, sponsor, partner, talk, whatever it is, communications will start separating. There will be a group that will separate about the program. Then we can have subsequent conversations on that. And then, of course, we have our public facing events, which we call, in this case, we have what we call cars and conversations. I know that something will be happening in Kenya very soon. So if you are from Kenya or East Africa, you can begin to look forward to that communication. Ghana and Nigeria too, something will be happening in those places. Thank you very much. Is there any question on what I just said? Let me see. I'm not on WhatsApp. Will I be added to the group? Dorcas, so send me a mail. If you have a WhatsApp number, send me a mail. I can look at it. I can, we can take it from there. Physical training, yes. Physical training, I spoke about it. So if you're from Ghana, like I said, for the ladies, we are trying to see if we can get some support for you. If the support does come, then some of you can come for the physical training in November. Mercy, you have a hand, you have your hands up. Any question? We want to wind down. Mercy, do you have a question? Okay, Dixon, your hand is up, please.
Yeah, well done, sir. I want to ask, would there be any of such training in Nigeria as well? For those of us that are from Nigeria.
Yes, yes. There was supposed to be a training in Nigeria, but for logistics reasons, it was postponed. But the team is working on something, so be expecting feedback. I on that note, I want to say something. Nigeria has been quite interesting when it comes to the space. For example, I was expecting for this program a lot of ladies from Nigeria. That didn't happen. I was surprised. So I said to Bob,
Maybe it's a thing of interest, actually.
That is the point. That is the point. So I sent a message to all the Nigerian people. Hey, you people, what is happening here? Yeah, disappointing the brotherhood and the sisterhood. You know?
I apologize on their behalf, but at least I'm a Nigerian.
No problem now. No problem. No problem. Okay,
I'm
is there
going to
somebody
be
else's hand who is up?
I'm going to be informed of the training when it's time for
Yes,
that
yes,
of
yes. Don't
Nigeria.
worry. Once you are in our database, so you'll be getting communications from us, but
Okay, sir.
some of the communication will be coming from me on a number of things. So there will be reports that will be coming out. You get communications on them. I mean, you get a number of communications. Okay.
Okay.
So don't worry about that. Yeah.
Thank you.
A part of the mailing list. Thank you. So, anybody has any question? I'm a Nigerian as well. Wow, hands are up. Oh. Listen, do you have a question, please? You want to close?
I just wanted to say that I'm a Nigerian as well and would like the training to happen in Nigeria too.
Oh, okay. Okay, I will drop a link for the Nigerian training, the paid program. You can just fill the form so that you will be on that mailing list. Okay, so when the dates come, all those people who have written their names will be indicated. Where are you based? In Lagos? Abuja?
No,
I'm
Federal
based
Capital
in
Territory, Abuja.
Abuja is far.
But if it's
But,
happening in Lagos, I can always go to Lagos. That's not a problem.
so if you can go to Lagos, then you can come to Accra. Come to Accra.
No, please, people should come to Nigeria.
Okay, no problem. Somebody saying that the information didn't reach many people as assumed. Oh, really? Okay.
We are no longer hearing you, sir. The line is breaking. Or probably I am no longer hearing you.
Oh no, I'm saying that that is it. You see, what was it? When he's saying that it's her colleague from who came to Ghana for a conference, the Future of Energy conference, who told her about it, which is true. Because I met the gentleman there and I shared the details with him. So over to you. Once we are going the network, we'll make sure that the information circulates across board. Okay.
Okay, sir. Sorry,
So
I just want to say something.
thank you
For
very much.
Yeah.
Okay.
For the training in Nigeria, I don't know if you can stick for a sponsorship from some vehicle. They just start producing electric vehicle now. So I think that's
Really?
one company look at for sponsorship. Yes.
Do you have a contact there?
I can try maybe through one or two connections.
Okay. Okay, so send me a message on WhatsApp. You have my number on WhatsApp?
Okay, yes, I have your number on the group. I'm going to save it, sir.
Everybody have my number. Okay, send me a message. Send me a message. And then we can start the conversation. We are open. But I will link you to one of our directors, Bianchit. She is currently in Lagos. You know, I think they are in what? Anambra State, right? Or
Yes. Yes, sir.
okay. So we can then start the conversation. Okay. All right. Thank you very much. Is somebody still raising their hand? Mercy, do you have a question or statement?
No, I
Mercy?
don't have a question. No.
Okay, you just raise your hand then. Okay. All right. Then hey, somebody is not joining. No. I think somebody is not joining. Credential. Okay, ladies, thank you very much. Credential, you are welcome. Unfortunately, we have closed. But please, the recordings, normally, what happens is that we have to trim it down to size. So by the weekend, the recordings will also come out. All right. Have a very lovely day.
You
In
too.
Kenya.
You too.
Thank
Thank you.
Yes,
Thank
Kenya
you.
will be
Bye.
communicated to you. Bye. So
Thank you.
if you
Bye.
hear,
Bye.
you will hear African EV, you hear EVTT. Please, everybody should drop on the WhatsApp their LinkedIn profile. Let us follow each other. I want all the ladies to follow
Yes,
each
that would be
other in
nice.
the group, and then
already, sir.
follow.
I'm following
No,
already.
I am not talking about me. Follow all the other ladies in your cohort.
Oh, that yes.
Yeah, so everybody should just
It would be
drop their
nice.
LinkedIn. Yes. Okay. So
It's
and
okay.
then please also comment. We are part of cohort 1. Share. Let the people know that we are part of a good
Comment immediately.
program. Yes. So
And you
I'm
didn't
waiting to
talk
see
about physical training in Kenya.
what do you say?
You didn't talk about physical training in Kenya.
Yes. The physical training happening in Kenya. The reason why I didn't say that is because currently we have for this quarter we have 2 trainings in Zambia, 1 in Ghana. Okay, and then we also have an event coming in November, like I was saying, the Cast and Conversations. All right. So we want to clear those events, clear the Cast and Conversations before we look at the training. But there will be a meeting next week that may affect whether there will be a training before the year ends in Kenya. Okay, but FYI, I would think that either December or by February, between December and February, there should be a training in Kenya. Okay.
Will it be? Excuse me. Will it be in Nairobi, or which place will it be?
Likely Nairobi.
Okay.
And
Thank you.
and there are also conversations. I don't know. So please don't hold me to it. There may be trainings in other parts of Kenya too, apart from Nairobi. Okay. That depends on certain conclusions that we need to have. But once those conclusions are had,
not yet. God, let me weigh in on that.
Okay, so John.
Yeah. So the Kenyan training, we are looking at it. The preparations are not as advanced as the other trainings, but that is something that will definitely come up. It will most likely, almost 90%, happen in Nairobi. So any new developments on that, and we will communicate that.
Okay.
Thank you for that clarification.
Yeah, thank you too.
Okay, so that is that. But we'll see how it goes. Okay. John, maybe you want to talk about the current conversation a bit, maybe giving some bit of deep background.
No, yeah, sure. The cars and conversations is we will basically be showcasing four-wheeler electric vehicles. Lots of people, some people even in the space, we noticed and realized that they do not know how quickly the space is actually progressing. I'll give an example. In the last 3 months, okay, BYD are launching, no, CFAO are launching the BYD. It'll be launched on the 25th of this month. There's a company called Moja EV that launched Neta vehicles. There's another, their showroom is on Mombasa Road. This is for the people in Kenya. And there's a company, Haval, which is a dealer of Nissan. They have launched a car called the Good Cat. And all this has happened in the space of 3 or 4 months. So a lot of things are actually happening in Kenya, and what we're trying to do is just get the public aware, you know, and really tell people that this thing is happening. This is happening, and you know, you guys should prepare. The tentative dates are on the 23rd of November. It will be happening at the Waterfront Mall. Yeah, and if you're in Nairobi, please come, interact with us, see what is going on. You know, I assure you, most of the industry will be there. So, you know, it's a good place to network as well. Thank you. Gad, are you trying to talk?
Yeah. I think, thank you very much, everybody. Have a very lovely day.